Hey guys, let's build intuition today. So, if you're new to the channel, one thing that we do differently is I not only tell you that, hey, this is a problem that will demand binary search, or we will use some algorithm and modify it, but also we discuss like how to read in between the lines and identify which pattern or which algorithmic pattern is going to be used while solving this question. So this is actually a very straightforward question, and there's literally nothing that they have mentioned in a very difficult or a very tricky way. It's very straightforward, where the question asks us to see if this array or if this list in Python has a duplicate or not. So they have provided an integer array, so we know that this list is strictly of integers. And another way to check this is by just looking here. Type hinting is very helpful in Python, so please pay attention to these things if in case you don't see building any intuition for this question. Then you know that you have to return true if any value appears at least twice. So just to exaggerate this thing, what can happen is your nums array can look like 1 1 1 1 1, and this is also possible. But for it to return true, this number 1 should at least be present for 2 times, or like the count for that should be at least 2. And if you don't find anything which is a duplicate, you simply return false, meaning that every element here is like a distinct number. Okay, so this is very straightforward. So I would like to take you on a journey from brute force to the most efficient solution. Let's start by the brute force approach. So to make things easier, I'll consider this first example. So when you look here, like the nums array has 4 elements starting from 1, 2, 3, and then we know already like there's a duplicate, but well, your code has no idea. A very naive way to do this, or like it's kind of also the brute force and probably the first hunch for most of the people, is that put a pointer here. So let's say fixate one thing here, like you are focusing on one. Let's assume this thing, right? You're holding 2 numbers, so in your left hand you're holding this 1, and then you keep picking the remaining part. Using the right hand, you just see this. Is this number equal to the number that I've already picked up in my left? It's 1. Oh, it's 2. No, it's not. Then you move ahead. You keep back this number 2 from your right hand, then you pick this number 3. You compare this again, what you have with in the right hand and the left hand. So you compare 1 and 3, they're not equal. Okay. You pick up the last number from your right hand and you see, oh, that's actually equal to the number that you are holding in your left hand. You got lucky and you return true. It is highly possible that this one is, let's say, 6. So you'll hold 6 in your left hand. You'll try for each of these numbers by picking up them one by one from your right hand. Once you come to this last number, you know, oh damn, you've executed everything, or like you've exhausted the remaining portion. Now let's pick 2 in your left hand. And then you do this, you repeat the same thing with the right hand, but for the remaining part of the array. So, you know, just to even explain this, I've spent like over like 4 or 5 minutes, I guess. And just to put things in perspective, you know, this is very inefficient. Let's say, so now even like, see here also, even I did not even finish iterating for the entire list. I just showed you for the first and the second version, where these 2 numbers are, you know, left hand. Imagine you have like this array that is having at least a million numbers, or more than that. So in that case, you know, right, you're doing unnecessary computations and again. And if you're familiar with time complexity, the time complexity, or like the space complexity to do this, is actually big of n square, wherein you're at least checking a number, like you're basically traversing the entire thing twice. So that's probably not what your interviewer would like to see you do. So now let's think of something else. Okay, first, like we discussed the brute force, that is like O of n square. Like the time complexity is very egregiously high, but when it comes to space complexity, it's nothing. It's constant, because you're not creating a new data structure that is kind of linearly scaling with the increase in your input. No, that's not happening. Can we do better? Yes. Now the second approach here is to maybe sort things. You may sort the array. So second approach here is of sorting. So let's take this nums again. Like you have your nums as 1, 2, 3 and 1. you may smartly actually sort this nums, and you may write it as 1 1 2 and 3, and then initialize 2 pointers left here, right here, and just keep checking this window. Or probably this can also be a sliding window with the length of 2. So you keep shifting this window, and you just check that is this number similar to the previous index. If it is true, then you return true. If you execute the entire array, and if you exhaust all the possibilities, and if you check for everything and still you have not returned true, you will simply return false. One caveat here, or another thing that you probably should be aware of, is that sorting is not for free, guys. Like it will take n log n. So again, like, you're adding unnecessary complexity into this process. So now let's build the final approach. So the third approach here is actually very, very efficient, and it is called as hash set, where you can create, let's say, a hash map, which is also called as a dictionary in Python, or else you can create a set. So the logic here is very straightforward. What you do is you create, let's say, a set which keeps a track of the numbers that you have seen. So currently there's nothing in your set, and you are traversing, let me copy this number, like nums array for your reference. And so now you're traversing for, like, you're iterating through all the numbers here. So this is your pointer, you're pointing to 1. Is 1 in your set? No. So you add 1 here. Okay. You move ahead, you are at 2. You ask this question again, like, is 2 in my set? Have I seen it? Or let's call this set seen, so that it's much more intuitive and it probably makes sense. Is 2 already in your scene? So have you seen 2? No, right? Like, then add it to 2. So now you've seen it. Okay. You move ahead, you are at 3. Have I seen 3 before? Like, you check it into scene. No, there's no 3. Okay, cool. Add this. But now is the case where you would probably handle the return of true. You are having 1. You're asking this question again, like, have I seen 1? Yeah, I guess I remember, like, I've seen it somewhere. And then you know, like, oh damn, it's the first element in your set. And then you return true. So what you're doing inherently here is that you're trying to maybe reduce unnecessary computations. So there can always be a case where you have more numbers here, like you have a 5, you have a 6, you have this, and you have this, and probably like a million more. So if you were to take any different approach rather than hash set, you would be adding up unnecessary computations. But when you are checking this condition of, have I seen this number before, you make sure that you are exiting on the very first occurrence, and you're not, so you don't even care. Like, it may happen that 5 and 5 repeats after this guy, but do you really even care, right? Like, it's just asking you how many, like, does it contain duplicate? So if the question would have been how many of these numbers are unique, or like how many duplicates does one have, then that's kind of like a very different game altogether. But like, given this question, already, like, this hash set approach is very, very efficient. And if you're feeling much more Pythonic, and if you feel a lot more adventurous, here is like this fourth very nifty little one-liner for you. So this kind of comes off from a very intuitive logic, or like, if you think, let me put it in this way. Let's go back to our comments. So now, if I were to create a set of this nums, okay, if I were to pass it to a set function and create a nums set, what would that look like? It would be like 1 2 3, because calling set on a list which contains duplicate just removes the duplicate and gives you an output of all the unique numbers that you have. So what is something that you're observing here? I guess you figured it out. It's basically the length of the nums set is actually less than, and not just less than, but strictly less than the original length of the nums. So if this happens, so if you come across a scenario where the set that you have created is actually less than the length of the original numbers, it basically means like there's a duplicate. Yeah, you just reduced some, repeated guy, and that's probably the answer. So how would you write that in one line? You would just return length of set of nums. What do you want to check? Less than. And can you write less than equal to? No, right? Like it's just like pointless if you write equal to, then, because you're not getting any evidence or you don't have enough data to say that. So you just write this like is it strictly less than the length of nums? And if that's the case, then you're good, right? You're all set. So this is one way. Now you might have a question like, hey, is this better than this hash set approach that we discussed? Then it's kind of tricky. It totally depends on what type of inputs you have. So if in case lot of inputs, or let's say the lists that you are getting as an inputs have super early exits. So for example, you might have a list of a length, let's say 500k, or it has like 10 lakh elements in them. So in that case, if you happen to find an early exit, then definitely hash set would work. But in other cases wherein, there is no early exit, or probably it's somewhere in the middle or things like that, this one-liners is okay. But the problem with this thing is, the amortized cost, or like the space complexity here is big of n, wherein like worst case, you will put everything that you have seen in nums. So in this case, see, this is like the explicit example where you hit the worst case space complexity. Here you look at 1, you added it to your set. You add 2, you check, is 2 there in your set? No, you add that. Is 3 there in your set? You was like, no, it's not there. Let's add it. Is 4 in my set? You're like, no, it's not there. Let's add it. And then you are done. So you've just created like a duplicate for no good reason. So in this case, like the space complexity kind of increases, but like the time complexity reduces very less. Like it's fairly, it's much faster than this brute force or this n log n type of solution. So just to quickly summarize what we have done right now. Okay. Like I'll also maybe create this. I'll write this hash set solution as well. So we initialize like a set variable for n in nums. It's just like a very Pythonic way of iterating through the list of elements. If n in scene, return true. Else. So, but do you really need else? No, right? Like you just push it, you don't care, right? Like you just add that number. The reason why you're doing that is because if hypothetically you were to encounter a number that's already in scene, you'll return true and nothing will execute. So you can just write it like scene.add and you push your number. If everything ends, I guess this for else syntax, wherein if and only if your for loop executes, you execute the else block, or else it won't. But it's not necessary. You can directly return false here, and then this also works. Let me test it out for you. And I don't know, LeetCode is like acting a little bit funny. Okay, yeah. So this works, and I hope this added a lot of intuition on your plate, and feel free to like stick with any of these approaches. So there are at least like 10 more different one-liners that you can find in this solutions section at LeetCode, and people have done like cool approaches. But just to tell you that it's not important to come up with these one-liners. It's not necessary. If you can, it's fine, but the point here is to just understand and make these informed choices, and talk in terms of space complexity and time complexity while you're interviewing. That is probably your interviewer is looking for, and I pray to God that you get this question in your interview. Good luck, guys. And if you have any specific requests, please let me know in the comments below. I'll be happy to take them. Bye-bye.